Hello, students. Now, in our classes, I have already introduced the concept of hypothesis to you all. Now, let's go in a detail for this. Okay. Now, I'll just revise a few points which we had already discussed. A hypothesis is an assumption that a population parameter. It is a quantitative statement about a population. Now, I had given an example about this, that what is this hypothesis is. Okay, it is an any assumption. For example, I had given an example of today all the 70 students will be present in the class. Okay, this is any statement. Okay, now this can be treated as my assumption or my hypothesis. Okay, so for example, now see, average heights of the boys studying in B farm is 170 centimeter. Okay, now this is also a assumption or a hypothesis. Okay, we need not know that this is really true or not. Okay, that the height of the boys is really 170 centimeter or not, or the average height of the boys, but this is a statement, I'm saying this. Okay, it is true or it is false is the next part, but it is a statement. Okay, or a given coin is unbiased. Biased means what? Partial. Okay, so unbiased is unpartial. So a given coin is unbiased. Now it is biased or not, it is the next thing, but it is my statement that it is unbiased. That is my assumption or my hypothesis. Then third is, the electric bulbs manufactured by a company will work for 1000 hours. Okay, now they will really work for 1000 hours or within 10 hours they will go off is the next thing. Okay, but the company is claiming that their bulbs work for 1000 hours. Okay, and that is the hypothesis or that is the assumption. Now let's move further. Now this assumption whether average heights of the boys studying in B farm is 170 centimeter or not. Now suppose if we consider our college or our semester 8 class. Okay. Now in this case, if suppose there are 30 boys, what is the procedure to test this hypothesis, that is whether this statement that their average height is 170 centimeter or not is really true or false. Checking this whether it is true or false, my procedure will be what? I will call out all the 30 boys in the class. I will measure their heights. Okay, I will have the data of their heights. Okay, h1, h2, h3. What I will do, I'll take the mean of that. We know very well how to take the mean. Okay, and I'll check that. Okay, this will be my practical example. Now, for this example, the electric bulb manufactured by a company will work for 1000 hours. One of the procedure is what? Taking all the bulbs and checking whether they really work for 1000 hours or not. But this is not a feasible thing. Okay? Similarly, a given coin is unbiased or biased. Taking Tossing it 1000 times or infinite times, I can say, you will able to know whether it is biased or not. But again, this is not a feasible region or not a practical decision. Okay, this one is a quite practical one, but this second and third are not quite practical. Why? Because lighting a bulb for around 1000 hours, and that too all the bulbs manufactured by a company will be manufacturing tons of bulbs, and so it is not at all a practical decision. Okay, so when such cases occurs, we have some formula or we have some steps in which we can test these hypotheses or these claims of these companies. Okay, so I have some procedure by which I can test this claim of this company that their bulbs work for 1000 hours, or I can test the claim that this given coin is unbiased. Okay, let's see how to do this part. Now, procedure for testing of hypothesis. Yes, whatever we say, testing the claim is the it is termed as testing of hypothesis or testing a hypothesis. Okay. First thing is setting up a null hypothesis. These are the common steps which we follow. Okay, setting up a null hypothesis H naught. Okay, that null hypothesis is denoted by this H naught. Okay, or H0 you can say. And what is this null hypothesis? This null hypothesis is any hypothesis which is tested for possible rejection under the assumption that it is true. Okay, this is the definition, but what does this really mean is that we put on a statement, okay, we assume that that statement is true, okay, and whatever results we get, based on those results we decide whether whatever we assume is really true or false. Okay, for example, now in this case, average heights of the boys studying in B farm is 170 centimeter. Now in this case I will set up that h naught is equals to height, average height is 170 centimeter, and I will proceed assuming that the average height of all the boys is 170 centimeter. Then whenever I will measure it them practically, okay, whatever decision I see, now suppose x bar I get to be 130 cent, oh sorry, 130 will be too less, right? 155 centimeter as the average height, then obviously I can say that my h naught is rejected, that is my h naught is false in this case, right? Why? Because there will be a lot of difference between 170 and 155. Yes. Now, or similarly, I can get this as, if I say in this case 170 centimeter, I have assumed that it is true, or that is my null hypothesis, and by practically measuring, I get x bar is equals to suppose 169 centimeter. Okay, at such points, since this 170 and 169 is a very small difference, I may say that this h naught or the null hypothesis or my assumption that the average height is 170 centimeter is true. Okay, similar is the thing in case of a coin is unbiased. Now in this case, my I will put on my h naught or my null hypothesis that a coin is unbiased. Okay, then based on this I will proceed further. Okay, I will assume that this thing is really true. Then here similarly in this case I will put that my h naught is the bulbs works for 1000 hours. Okay, I will assume that they really work for 1000 hours, and then I will proceed further. Okay, and if further I find out if they work only for 750 hours, then I will say that my H naught or my assumption or my null hypothesis was false. Okay. Now, so this was about null hypothesis. Now let's see about the alternative hypothesis or the alternate hypothesis, one and the same. Now, see, now H naught is something, now anything opposite to H naught or anything complementary to null hypothesis is called as alternative hypothesis, and it is denoted by H1. So H naught and H1. Now anything opposite to now this null hypothesis, that means now suppose I'm saying that average height of the boy studying in B farm is 170 centimeter. This is my H naught. Okay, what will be the opposite thing to this, that the height average height is not 170 centimeter. Okay, so that will be my h1, not 170 centimeter. Now similarly in this case, see, a given coin is unbiased, that is my h naught. Okay, so h1 will be what is opposite to being unbiased, being biased. So I will say that h1 is a coin is biased. Okay, so this is my alternate hypothesis, the exact opposite thing. Now, or the electric bulb manufactured by a company will work for 1000 hours. Now suppose this is my h naught, what will be the opposite, that they will not work for 1000 hours. So that will be my h1, not work, right? So these are the things, this is the, so these concepts are actually very easy, that whether it is a null hypothesis and set, if once the null hypothesis has been set, it is easier to set the alternate hypothesis, writing the exact opposite of that. Okay. Now we have, yeah, a few more examples. Extra coaching has benefited the students. Okay. Now see, this, if I put this as my H naught, what will be my H1? That extra coaching has not benefited the students. Now, second example, corona vaccine is not effective. Now, if I put this as my H naught or this as my null hypothesis, what will be my alternate hypothesis? Corona vaccine is effective. Okay, so this is the only difference. Now, yes, now this there is one another statement. The average weight of the student in our college is 60 kg. Yes, I will say that this is my H naught. Okay. Now let's say this is my null hypothesis H naught. Now, if I want to represent this statement mathematically, okay. So mathematically, what I can say, see now suppose weight, average weight, I write this as W. Okay. So that is what W is equals to 60 kg. Okay. So this I can write that average weight W implies or like this H naught average weight is equals to 60 kg, average weight of the students in our college. Now H1 will be what? This weight is not equal to 60 kg. Okay, this is one thing. Or I can even write H1 as this weight of the students in our college is greater than 60 kg. Or even I can write this as the weight of the students is less than 60 kg. Okay. Yes, this now writing this H1 as weight not equal to 60 kg is quite direct. But there can be some uh, problems in which I need to calculate it in this manner. That is, weight is greater than 60 kg is also possible. That means it is again this thing only, that it is not equal to 60. Weight, that average weight can be less than 60 kg. Now that condition is also possible. That is again a part of this thing. Okay. So when my null hypothesis is weight is equals to 60 kg, and I put on this H1 as weight not equal to 60 kgs, this is called as two-tailed test. Okay, that is what in this case, this example, even weight less than 60 and weight greater than 60, both are covered in within this part. All right. And now this weight strictly greater than 60 kg or weight strictly less than 60 kg, they are called as one tailed test. Okay, that is what, they are only going into one direction. Okay, in this both less than 60 or greater than 60, both are allowed in this case. Now in this case, only weight which is greater than 60 will be considered, and in this case when it is only less than 60 it will be considered. Okay, so that's why it is called as one tail, and this is a two tail test. Okay, so after setting, the first two steps were this, that setting up a null hypothesis for any test. Okay, now if you see here, here there was an example. Now 170 centimeter, the height of the boys were 170 centimeter. I have again H1 can be height not equal to 170 centimeter, or height less than 170 centimeter, or height greater than 170 centimeter. Okay, this was one tailed test, and this was the two tailed. Okay, now if you see this, a given coin is unbiased. Now in this case, you have only one option, okay, that a coin is biased. Okay, there you cannot have any more alternate hypothesis. Okay, so only one kind of alternate hypothesis is allowed in this case. Now similarly, this electric bulb manufactured by a company will work for 1000 hours. Again my h1 can be, will work for not equal to 1000 hours, will work for less than 1000 hours, or will work for more than 1000 hours. Okay, anything is possible. But but if my statement is like this, that the electric bulb manufactured by a company will work for at least 1000 hours. Okay, now at least 1000 hours means these things will again change. Okay, now at least 1000 hours means my h naught will be, the bulb manufactured by a company will work for at least 1000 hours will be my h naught. So now my H1 will be what? They will not work for at least 1000 hours, or that is what, they will work for less than 1000 hours. Okay, so this will be the only H1 possible. Now if I write this as H1 W, or work for greater than 1000 hours, then it is true, that is again equal to H naught. Okay, or if I even write this as H1 is equals to W not equal to 1000 hours, then again it will be equal to H naught. Okay, so in this case the only alternate hypothesis which is possible is this one, that is H1 working for less than 1000 hours. Okay, so this is the way how we have to set up the alternate hypothesis based on the null hypothesis given. Okay, so these were the first two steps. That first step was setting up a null hypothesis. Second step was setting up a alternative hypothesis. Third step is setting up a suitable significance level. Again, I had explained this level of significance, or the significance level. Either it is 5% or 1%. Okay, this I had explained, and we have even solved some testing the significance of correlation coefficient and all. We have done this part. Okay, at that point of time I had explained how, if it is 5%, how we see the values in the chart. If it is 1%, how we see the values in the chart. Okay, fourth one, setting a test criteria and computing. And fifth point is making a proper decision. Okay, setting a test criteria. Now if you remember, when we had done one example about calculating the significance test for the correlation coefficient, at that point of time I had taken this example: t is equals to some r root of n minus 2 upon 1 minus r square. I guess such kind of t value was defined, and when once we had solved, r was the correlation coefficient and n was the number of observations. Okay, so if you remember, we had solved this, put the values, and we had found the value of t, and based on what this value was, we had accepted or rejected the value, or we had either accepted or rejected that correlation coefficient is true for the entire population or not. Okay, now when such kind of proper, for this was for the smaller samples. Okay, when a large sample will come into picture, and now large sample means what, when the number of observations, or when this n value, sample size value, is greater than 30, it is regarded as the large sample. Okay, in that case we have this test statistic, or the test criteria defined to be t, it, t minus expected value of t upon standard error of t. Okay, just keep in mind this value for now. I will explain this. Okay. Now, why this particular value is because, see, whenever it is a large population, or the population, or sorry, large sample, that is sample size greater than or equal to 30, it is by default assume that it follows a normal distribution. Okay, I had explained this normal distribution is a universal distribution which we see in our nature by default. Okay, so whenever a sample is very large, it is by default assumed that it follows this normal distribution, and everything of all criterias or all problems revolve around this normal distribution. Okay, so that is the reason this is how it is written. This test statistic is written, and it is sometimes even written as n01. Okay, now n01 is, n stands for normal distribution, that is it follows normal distribution. 0 is the mean of the mean of the distribution, and 1 is the variance. Okay, or the standard deviation. It is one and the same. Okay, in this case it is one and the same. Why? Because, see, variance is equals to standard deviation square. So if variance is 1, standard deviation will also be 1. Okay, so in this case, it is either variance or standard deviation. We take it as per our convenience. Okay. Now, what are these values? Z is equals to t minus e of t upon standard error of t. I'll just explain. Now, now suppose I want to test about the mean of a sample. Okay, mean, any average mean. Now, for a sample, it is x bar, and I had told that for when it is for the population, it is regarded as mu. Okay, so now see, t will be, this is the observed value, that is this value comes from the sample. Okay, and this e of t is the value of the population, or we can even say that as the expected value of t. Okay, so if I want to calculate the z or the test statistic for this mean, how it will be? It will be t will be replaced by x bar minus, now the mean for the population, or the e of x bar will be what? Mu upon the standard error of x bar. Okay, now this standard error, now standard error is different for different kind of comparisons. Okay, now as for the regression coefficient, you had regression coefficient b, we had defined the standard error as some root of 1 upon n minus 2 and blah blah blah, if you remember. Okay, similarly, for if it is comparing the two attributes, the standard error is defined by p q by n, where n is the sample size, p is the probability of the attribute in the population, and q is for the that probability of failure of the population. Okay, so like it is same as small p and small q. Okay, but the small p and small q are for the sample. Okay, and for the population we have capital P and capital Q. Okay, and one and the same relation again, p plus q is equals to 1. Okay, so same relation. So like this, the standard error keeps on changing. Okay, that is, you have different formula for different kind of errors. Okay, now once this value has been calculated, that is, you need to calculate this z value. Okay, and finally whatever value, calculated value you get, based on that you have to make your decision. Now what is your decision about? Decision is about accepting the null hypothesis or rejecting the null hypothesis. Okay, that is, whatever assumption you have made, you will say either it is correct or wrong based on whatever this z value you get. Okay, now how to do that, I'll just explain. Now see, I just had repeated this, that by default we assume that large samples follows the normal distribution. Okay, and with this here lies your x bar or mu, sorry, and then, or a mean I would say for simplicity. Then I had even explained in earlier videos that here lies your first deviation, standard deviation, here is the second standard deviation, here is the third standard deviation, or something like this. One standard deviation, second standard deviation, and a third standard deviation. Okay. Now, based on this, I had said that the area between this second standard deviation, these second standard deviations, is around 95%. Okay. And the area lying within this third standard deviations is about 99%. Okay. Now, if any value you get, whatever z value, suppose I can say theta, calculated z value theta. Now, if that theta value lies either here, that is outside this 99% region, that is here, suppose. Now, in that case, if your level of significance is 1%, okay, I'll just say this. See, set my third step of my testing of hypothesis procedure is that set up a suitable significance level. Okay. Now, setting up a suitable significance level, that is either 5% or 1%. Now, see, 5% here and there, that means you have the 95% chance of acceptance or confidence. Okay. 100% minus 5%, that comes to 95%. Okay. And similarly, if it is 1% chance of significance level, that means you have 99% confidence level. Okay. So this is what it is. This is 95% confidence level, that is 5% level of significance. Now, in this case, it is 99% confidence level, that means 1% level of significance. Okay. Now, at the third step, suppose you have set up that it is 1% level of significance. Okay. Then, if you are getting your theta value somewhere here, okay, that means you are rejecting the null hypothesis. Okay. Here this theta value, either it is crossing this 3s or this 3s. Okay. That is, in these regions you will reject the null hypothesis. But if your theta values lie somewhere here or somewhere here or within this shaded region, you will accept the null hypothesis. So shaded region, accept the null hypothesis. Okay. So this is the only thing. Now, rejecting the null hypothesis means what? Accepting the alternative hypothesis. Okay, one and the same, vice versa. And similarly, accepting the null hypothesis means what? Rejecting alternate hypothesis. Okay, just keep this mind up. Accept H naught is same as reject H1, or reject H naught is same as accept H1. Okay, just keep these two things in mind. Why? Because these terms will be used alternatively. Okay. Now, similarly, now this was at level of significance 1%. Now, similarly, at that third step, if you assume that your level of significance is 5%, you will look for this graph. Okay. Now, in this case, if your z value or the theta value lies within this region, you will accept the null hypothesis. Okay. And if your theta value crosses this, that is theta here or suppose theta here or suppose theta here, then what you will do is reject H naught. So accept H naught in shaded. Okay. Otherwise reject H naught. Okay. So this region, this shaded region is called as acceptance region. Okay. And this unshaded region or outside this acceptance region is called as rejection region. Okay, this part I had slightly explained in the class also. Now, once this testing has been done, whether once you have accepted or rejected the hypothesis or your final decision has been made, now since a population is very large and the sample which you have collected is a quite small number, there are chances for errors. And what kind of errors in this? Now, see, the errors can be when H naught is actually true, but you may reject it. Okay? Or when H naught is actually false, you may accept it. So such kind of errors can occur. So this is what it says that see this table. H naught is true, but if you reject that H naught, then it will be a wrong decision. Obvious, no? When H naught is actually true, but you are rejecting that by due to some human errors, or you can say your samples were not correct or anything or wrong procedure. Okay, so in that kind of case you will reject your H naught. So that will be what your wrong decision, and such kind of error is called as type 1 error. Okay, now if that H naught is true and you accept that H naught, that means it is correct decision, that is you have solved the problem correctly. Okay, now now re it's not about solving the problem correct or not, but getting a correct result or not. Okay, now second case can be what? H naught is false. Now, that is null hypothesis is actually false. Now, when it is false, if you reject it, that means it is correct. And if that H naught is false, but still you accept it, that means it is a wrong decision. And such kind of thing is called as type 2 error. Okay. So, these errors, type 1 and type 2 errors, now that is defined as rejecting H naught or rejecting the null hypothesis when null hypothesis is actually true is called as type 1 error, and uh, accepting the null hypothesis when the null hypothesis is actually false is called as type 2 errors. So such kind of questions can occur. Huh? Write a short note on type error 1 and error 2, or write a short note on a testing of hypothesis. Okay, I think this part, whatever this part is, should be enough, or this video should be enough for you all to write the note on this testing of hypothesis and these types of errors which may occur. Okay, so I will not give a separate note on this testing of hypothesis part. Okay, now I'll just try to solve one example. Now suppose a die is tossed, suppose 9,000 times. Okay, and out of that total 3,500 times, or I'll say 3,600 times, it get we get a 3 or a 4. Okay, is the die biased? Check at 1% level of significance, and tabulated value is suppose 1 point, sorry, 2.26. Okay, now, or this may not be given. Okay, now a die is tossed 9,000 times. Now see, and it is asked that it gets 3,600 times, we get a 3 or a 4. Is the die biased? Okay, now about this biased die, or being biased or not, or having a weight equal to 1, or height equal to 170 or not, or a weight equal to 60 kg or not. Now these are two different things. Being biased or not, these are some qualitative aspects. Okay. And weight or height, they are some quantitative. This I had explained already, okay, in the class. Now this biasness is kind of qualitative attribute, okay. So we proceed with this, that H naught, my null hypothesis is die is not biased. Okay. Now, so what will be my H1? H1 will be die is biased. These things are easy. Okay. Now, starting off level of significance. Level of significance, only the question has directly given, that is 1% level of significance. Okay, this even represented by alpha. Sorry, 1% in the sense alpha is equals to 0.01. Okay, that is what 1% means, 1 upon 100, that comes out to be 0.01. Okay, therefore alpha is equals to 0.01, or if it is 5%, it would have been alpha is equals to 0.05. Okay, that is the only difference. Okay, now level of significance has been found, that is first three steps have been done. The first three steps should be very easy. Now, going to the fourth step. Fourth step is what? Setting up the test statistic. Okay, test statistic. Now, I have the formula already, that is Z is equals to T minus E of T upon standard error of T. Okay, now this T will be what? Being biased or not. That is the probability. Just a minute. Okay. So in this case, you will have to calculate the probability. Probability of getting a 3 or 4. Okay. Now, now getting probability of getting a 3 or 4 is actually what on a die? Represented by capital P. It is what? 1 by, sorry, 2 upon 6, that is 1 by 3 is the probability, or I can say 0.3333. Okay, now this will be in general when a die, or when an unbiased die is thrown. Okay, you get, this is the general probability. Okay, now that is what the probability of the success. Okay, now what will be the probability of the failure, capital Q? It is 1 minus P, that comes out to be 1 minus 1 by 3, that is 2 by 3. Okay, so this was for the, this both parts were for the population, or this was my E of T part. Okay, since I'm testing the probabilities of getting that. Okay, that is what, if the probabilities are equal, that means, or the probability of getting any value, or any value on the die is are equal, that means what, this die is unbiased. Okay, now for from sample, what I can get, the probability of getting 3 or 4, that was what, the small p. Okay, and that was what, how many times I got a 3 or a 4, that was 3660 times. Okay, sorry, 3600 times. And how many times it was thrown? 9000 times. Okay, so this is the observed probability, or small p value, but it is the observed one, that is the from the sample. So what does this comes out to be? This 0.36 by 90, that comes out to be 12 by 30, that's again, I can say this as 2 by 5. Okay, 2 by 5. So Q value will be what? 1 minus 2 by 5, that is 3 by 5. Okay, this is for this small p, and this small q is from the observed. Okay, so now how you will define this, what you will write is you will substitute these values in this test statistics, that is t minus e of t upon standard error of t, that is now t. In this case of t, now you have probabilities, so small p minus the expected value of p upon the standard error of this small p. Okay, so that it will be what? Small p is what? Small p I have found out, that is the observed value from the sample, 2 by 5 minus expected value of p, u of small p is same as the expected value of the population, or the population value which we have got, that comes out to be 1 by 3. Okay, and the standard error of p is given by p q root of pq by n. So I have 2 by 5 minus 1 by 3, and p, capital P is what? 0.33, or I can say 1 by 3, I'll write it. Q is what? Capital Q is 2 by 3 divided by n, and what was n? N was 9,000. Okay, so when you solve this, whatever value you will get, based on that value, suppose I have got some x value, based on that I will decide whether to accept or reject my null hypothesis. My null hypothesis was accepting the, sorry, my null hypothesis was the die was biased. Okay, now whatever this x value, now this x value, now since it is about 1%, I will look for this. Okay, now if this value lie, whatever this x value, now if this x value lies outside this region, this shaded region, I will reject it, or somewhere x here or x here, I will reject null hypothesis. Or and if this x value lies within this shaded region, I will accept null hypothesis. Okay, now if I am rejecting this null hypothesis, that means conclusion is what? Die is biased. Okay, and I'm accepting the null hypothesis means what? Conclusion is what? Die is unbiased. Okay, so this will be the end of your problem. Okay, so either these two cases can occur, this one or this one. So I think this should be enough for the null hypothesis part.